All right, guys, welcome back. So back to Foundational 15 of Chapter 5, the demonstration. It's not a demonstration problem, by the way. It's a problem that we are asked to solve. So you're supposed to be solving it, but there is a review problem that is solved. So if you are interested in finding out at least one worked out problem, then please refer to the review problem. But you have to solve the Foundational 15. Anyway, so this is the key information on a unit basis. So I have unitized it on a per unit basis. You can see the unit selling price is $20 because the total sales for 1,000 units is $20,000. That means for one unit is going to be $20. And likewise, the unit variable cost is $12. So that leads us to contribution margin per unit, or UCM, of only $8. So after $8, you have to take a pause, and then total fixed cost. Do not unitize the fixed costs. Try not to unitize it. Keep it as a whole, because that represents the whole operation for the period. So for 1,000 units, or between any number of units between 5 and 15, 500 and 1,500, is going to be $6,000. So total fixed cost is $6,000 for the whole operation. All right. So in the contribution income statement, you have seen that $20,000 was revenue, $12,000 was variable costs, and contribution margin, of course, was $8,000 minus $6,000 of fixed costs, left us with net operating income of $2,000. So that's also a pertinent information. All right, so right now the NOI, as I also picked it up, the NOI from 1,000 units level, 1,000 units of sales was $2,000, and the contribution margin at that level, contribution margin for the whole operation at that level, was $8,000. Remember, contribution margin is no guarantee. Contribution margin on a unit basis is $8,000. So for 1,000, sorry, on a unit basis was $8. So for 1,000 units, it was $8,000. But if the number of units drops to say 900 or 800, then contribution margin or total contribution margin would drop, although unit contribution margin would remain the same. So here there are certain things that are fixed, like unit variable, unit selling USP. On a unit basis, selling price is assumed to be fixed. So unit selling price is fixed, unit variable cost is fixed, and unit contribution margin is also fixed. But total fixed cost is fixed, but unit fixed cost is not fixed. Unit fixed cost is actually variable, and it drops as we produce and sell more and more and more because of scale of economies of scale. Anyway, so our current level, our net operating income is $2,000, and our contribution margin is $8,000. So we have all the information that we need to solve a host of problems, whole range of it, whole range of them, range of problems. So number one was the unit contribution margin. So they wanted us to calculate unit contribution margin, and you know what it is. We already had it in the key information. So we know that unit contribution margin is the difference between unit selling price and unit variable cost. So our unit selling price was $20 and unit variable cost was $12. Therefore, unit contribution margin must be $8. So that is the answer to the first problem. The second was CMR, or CM ratio. So once you know the CM, once you know CM on a unit basis, then we divide it by selling price. So $8 by $20, or 8,000 by 20,000. Same, it's the relationship I told you in the previous video, in the one before my previous video. All right, so contribution margin ratio can be calculated from either unitized information, or unit-based information, or from the total operations, because it's a relationship between two variables. So we did it between unit contribution margin and unit selling price, and we found it to be 0.40. All right, so we have the same ratio, and you have seen the alternative calculation. You can see the alternative calculation here too. Next is number 3, the variable expense ratio. Now, variable expense ratio is one that I didn't mention in my main presentation on CVP relationships. Variable cost ratio is actually 1 minus CM ratio. Remember, it's denoted as a small v. 1 minus CM ratio is variable cost ratio. It is not selling price minus variable costs, but it is selling price then minus contribution margin by you have to have that 1. So 1 minus CM ratio. So that means if we have the variable costs of, if our variable cost is $12, then variable cost divided by sales would give us the variable cost ratio. Yes. So if we can go either 1 minus CM ratio gives us variable cost ratio, and that means CM ratio and variable cost ratio together is actually 1, as is contribution margin and variable expenses is equal to selling price. Of course, they have to be equal because our selling price is divided into 2 streams, 2 components. One is the variable expenses, another is contribution margin. Because from selling price, if we subtract variable expenses, we get, variable selling price per unit. If we subtract variable cost per unit, we get unit contribution margin. Or if we have total selling price or total sales revenue, and if we subtract the total variable expenses for that operations level, for those activity level, then we get the contribution margin for the whole operations. In any case, the 2 together is equal to the selling price or sales revenue. All right. So it has to be 1 minus CM ratio because the CM ratio and variable expense ratio together is 1. All right. So that is 0.6. Another way of doing it is divide our variable expense per unit, which was $12, by selling price per unit, which was $20. So 12 by 20 is also 0.6. Or total variable costs, total variable expenses of 12,000 divided by total revenue of 20,000. That would also give us 0.6. It's amazing that there are so many ways you can get to the same destination, and that's important for you to check, because if you know it correctly, if your knowledge is complete, then you'll be able to approach it from a number of ways and still get to the same destination. All right. Number 4 was if sales increases by 1 unit, it's marginal. It's like we're doing microeconomics. So if sales increases by 1 unit, by what amount would our net income or net operating income increase? All right. So you can see sales is the top line and net operating income is the bottom line. But if there is any change in the top line, of course, there will be changes in the bottom line, unless there is a compensating change somewhere in the middle. So the question says, if sales increases by 1 unit, so if it increases by 1 unit, then our revenue increases by $20. And of course, to sell 1 extra unit, we have to manufacture it, don't we? So if we manufacture it, we have variable expenses. So for every extra unit, we would receive some revenue, but we'd also have to incur some variable costs. Otherwise, it wouldn't be called variable costs if it wouldn't vary. So for 1,001 units, we will have extra, how much? Extra $6, extra $12 of variable expenses, isn't it? Our selling price our sales revenue would go up by $20, but our variable costs would also go up by 12. So our contribution margin goes up by 8. But our fixed costs remain fixed. So the increase in contribution margin would directly contribute to an increase in our net operating income. There's the advantage of operating above break-even point. If you're above break-even point, then any increase in sales directly contributes to your variable expenses, and the rest of it goes to profit. In other words, any increase in contribution margin directly contributes or is equal to increase in profit, because fixed costs cannot change. They are called fixed. So they're fixed for a reason. If they would change, then they wouldn't be fixed costs anymore. Anyway, so the answer is $8, because unit contribution margin is $8. So if our sales increases by 1 unit, our net operating income would increase by $8 here. Then question 5, if sales decrease, if it decreases by 100 units, oh my God, if there's a big decrease, 10%. If it decreases by 100 units, then what would happen to our net operating income? Now you tell me. So if sales decreases by 100 units, nothing would happen to our fixed costs. Fixed costs wouldn't drop at all. So fixed costs would remain the same. So if it remains the same, let's leave it. So what would happen to our variable expenses? Of course, our sales revenue would drop and our variable expenses would drop too. So that means our contribution margin would drop. So our contribution margin would drop by how much? It would drop by 8 times 100, because contribution margin per unit is $8. So there are so many ways you can do it. One way you can do it is, okay, let's see how much our sales would drop by. selling price per unit is $20. So sales would drop by 20 times 100, which is $2,000. So sales goes down by $2,000. Variable expenses go down by $1,200. That means contribution margin goes down by $800. And if contribution margin drops by $800, net income would drop by $800 as well, because fixed costs would remain the same. Nothing would happen to that. So the answer is our net income would drop by $800. So you can see I did it in a very shortcut way. All I did is multiply 100 by the unit contribution margin, because the sensitivity in sales and variable costs are in opposite directions. If sales drop, then that's a bad news. But slightly good news is that our variable expenses will drop too. So when sales drop or sales revenue drops, then variable expenses drops as well. That's why the contribution margin doesn't drop by as much, because sales dropped here by $2,000, but contribution margin dropped by only $800, because we saved a little bit on variable expenses, which is $1,200. So the drop in contribution margin, the $800 drop in contribution margin, is dollar for dollar drop in our net operating income. That's why the answer is $800. Number 6 is, if selling price or unit selling price goes up by $2 and if variable expenses remain the same, then what would happen? What would happen to our net operating income? So see, sensitivity analysis, one of the things that we talked about in the penultimate video. So see, the question said that if unit selling price goes up by $2, so I recorded new selling price, a new USP as 22, new USP and new UVC is unchanged as the old one, so that's $12. That means our new unit contribution margin is now $10, isn't it? Better than the previous 8. And our new net operating income. So net operating income is now based on 900. Yeah, they also said that when our unit selling price goes up by $2, our demand for our products would also drop. So if we'd be selling only 900 units, our sales drop by 100 units. So that would mean we're going to be making $10 on a unit basis, $10 per unit on 900 units only, not on 1,000 units. So 900 units times 8, $7,200, $7,200. So that would be our, sorry, not 8. Our unit contribution margin is actually 10. So 900 times 10 is $9,000 minus fixed costs of $6,000. Fixed costs, there's no change in fixed costs. So the answer is $3,000. Let me repeat. The question was about unit selling price to go up by $2, total sales dropping to 900 units. So what's the impact on net operating income? So we calculated new unit selling price, which was 22. New variable cost the same as old, so it was 12. So new unit contribution margin is $8 a unit. So $8, if you keep making $8 on 900 units, oh, sorry, why I keep saying $8? It's actually $10, because 22 minus 10, sorry, 22 minus 12 is actually 10. Yes. So new selling price is 22. New variable cost, same as the old variable cost, is 12. So new unit contribution margin is $10. $10. So if we keep making $10 on each unit, how much we make on 900 units? Of course, $10 times 900 is 9,000. So we'll be making 9,000 units, and then we subtract the fixed cost, then our profit would be $3,000. Okay, I think I'm talking a bit fast, so I'll try to slow down. The number 7 was that if variable cost goes up by $1, variable cost used to be $12, but if it goes up by $1, that means if it becomes $13, and we keep selling the same number of units, then what would happen to our net operating income? All right. So we don't sell the same number of units. We sell now more units. We sell $250. Sorry, 250 more units. So new variable cost, new selling price, our unit selling price would still be $20. So we go back to the original information. Selling price is $20. Variable cost is 13. That means contribution margin per unit is now $7. So total fixed cost goes up by $1,500. So they said that we have to spend $1,500 more on advertising. So advertising cost here is going to be a fixed cost. Why fixed cost? Because you can't advertise for every unit. So you have an advertising campaign, or you send a message, you publish something, you broadcast something, you telecast something. or your billboards. So you spend a certain amount of money, no matter how many units you produce or sell. So that's why it's a fixed cost. It doesn't go by the unit. So new total fixed cost is going to be $7,500. Originally was $6,000. Now $1,500 more. So that's $7,500. So unit contribution of $7. So the new sales volume, they said it does increase our sales volume to 1,250. 1,250. So that means the new operating income now. You tell me the new operating income must be number of units times unit contribution margin minus fixed cost. So number of units is 1,250. You can see NOI is unit sales times unit contribution margin. We not just anyone doing managerial accounting in a professional way, they would not every time, unless there are changes, they would not start from sales, because sales and variable costs, they usually go hand in hand. So if you have say 1,250 units, you'd be receiving revenue on 1,250 units, and you'll be spending variable costs on 1,250 units as well. So you're better off doing it as if everything's happening on a 1 unit basis. So my selling price was $20. My variable cost was $13. That means my unit contribution margin is $7. So I'd be making $7 on every unit for how many units? For 1,250 units. So we start from contribution margin to find out net operating income whenever there are changes. So let's see. Not even whenever there are changes. I mean, you could do the actual. I mean, you could like the very first one. At the very beginning, we were given sales and variable costs and contribution margin. That was given because we needed to be given the information at least once. But once we know the unit selling price and unit variable costs, then we don't need actually the total revenue and total variable expenses. We just need the number of units, and we will straight multiply it by our contribution margin, unit contribution margin. So that's what I did here. Our operating income is going to be 1,250 units times the $7. So that's our total contribution margin minus fixed expenses. And fixed expenses here are not $6,000. It's going to be $7,500. So our profit now is $1,250. Net operating income is $1,250. This is so because we couldn't increase our revenue. Our revenue didn't go up. We were still selling it at $20 each. So we're making less contribution because our variable costs went up by $1. So making less on a unit basis, but luckily we sold more units. We sold 1,250 units instead of the original 1,000. But that extra revenue or extra contribution margin is eaten up by extra fixed costs. You can see, say for 1,250 units, 1,250, we would be losing one. Previously we used to sell 1,000 units and we used to make $8,000 in total in contribution, because unit contribution margin was $8. So 1,000 units at $8 was $8,000. Now although we are selling more, 1,250, but at $7 we are making only extra $750. But if we went back to the original information, our contribution margin used to be 8,000. Was 8,000. Now with extra units, because of an increase in variable costs, even though we are selling 250 more units, our total contribution margin is still only $750 more than the original 8,000. So there's extra $750 would have contributed to our profit. Our original profit was $2,000, but now the profit has gone down, because although our contribution margin has gone up, but our total fixed cost has gone up by even more. The total fixed cost has gone up by $1,500. So we are actually $750 worse off. The contribution went up by $750, but our fixed cost went up by $1,500. So we are actually $750 worse off, and that's what happened here. Our original net income was $2,000, but now it's $750 fewer, less than the original 2,000, which is now $1,250. So that's number 7. Now let's go to number 8. The real question, break-even point in units. We know that it is TFC by UCM. So TFC was $6,000, UCM was $8. So the break-even point is 750 units. Now simply multiply it by $20. 750 times 20 is 15,000. So, but we didn't do it in that shortcut way. We used our proper formula, because break-even point in dollars or in amount is TFC by CMR. Our CMR was 0.4. So TFC was 6,000. So 6,000 by 0.4 is actually $15,000. But it would be the same if you multiplied it by unit selling price. 750 units breaks you even. So multiplied by $20, that amount of 15,000 would break you even too. All right. Then number 10 is required sales. Now the target profit analysis. We want to make some profit. Of course, everyone does. So how much profit would like to make? They said would like to make 5,000 units. 5,000 units. So our fixed cost was already $6,000. Add the $5,000 of extra profit, the desired profit. So TFC plus TY divided by UCM. So TFC was 6, TY was 5, so 6 and 5, 11. $11,000 divided by 8. That would give us the required sales in units. So I'll leave you, I'll leave it for you to calculate. Then they didn't ask us required sales in dollars, but if they did, we could do that too. We would have done that same $11,000, would have divided it by 0.4, the same ratio. Well, now margin of safety, when a margin of safety is sales minus break-even sales. So sales, a margin of, whatever there is a question of margin of safety, one has to clearly ask you at what point, because margin of safety is different as your sales level, sales volume goes up and down. For example, at break-even point, margin of safety is 0. At below break-even point, margin of safety is negative. At above break-even point, there is margin of safety, but as every unit change, as the number of units changes by 1 unit, my margin of safety keeps changing. So at 10,000 unit level, I'm sorry, at 1,000 unit level, what was our margin of safety? So we said it is sales minus break-even sales. Our sales was $20,000 and break-even sales was $15,000. So that's margin of safety in dollars. But margin of safety could be in units as well. How many units of margin of safety do we have? There would be 1,000 units minus 750 units. So 250 units. 250 units. If you sell 250 units at $20, you'd be selling them for $5,000. So in any possible way, you are the same solution. Number 12 is MS percentage or MS ratio. So MS percentage is margin of safety divided by current sales. Margin of safety was $5,000 and current sales is $20,000. So we have a 40% margin of safety. Then degree of operating leverage, DOL. Remember, by what percent our operating income changes for every 1% change in sales. That is the degree of operating leverage. So we could do it in a like detailed way by having different scenarios. Like one way of doing it is that you have the current sales, current contribution format income statement, and they do a new one with 1% extra sales or 10% extra sales. So your current sales is $20,000, your 10% extra would be $22,000. Your current variable cost is $12,000, your new variable cost would be 10% more. It would be $13,200. That would lead you to a new contribution margin minus the $6,000. So you'd have a new operating income, and then compare, then see by what percent your new operating income has gone up over your original operating income. But there's a much easier, much smarter way, is that DOL is at any particular level, DOL is contribution margin by net operating income. So our contribution margin right now is $20,000 minus 12 is $8,000. So contribution margin is $8,000 and operating income is only $2,000. That means we have a degree of operating leverage of 4. That means if sales go up by 1%, our operating income would go up by 4%. We're in a very good situation, very, very sensitive situation. Sensitive because what if our sales drops by 1%, then our operating income would also drop by 1%. Sorry, it would drop by 4%. Double-edged sword. Okay, now 14 and 15. It says, what if our variable cost changes? Like, what if the variable cost and fixed cost, they swap places? Right now, our fixed cost is $6,000. So what if, and our variable cost is $12,000, variable expenses they call. So if they swap places, that would mean the new variable cost is going to be $6,000 and new fixed cost would be $12,000. We'll still be making some profit. That's true, because our total cost is still going to be $18,000 and our sales revenue is $2,000. We'll still be making the same $2,000 of profit, but a lot of calculations would change. For example, our break-even point would change, our sensitivity would change, our degree of operating leverage would change, and even our margin of safety would change. So let's swap those places. So that would mean the new TVC, new total variable cost, would be $6,000 and new TFC would be $12,000. This is the first time I'm using total for variable costs. All right, so that means our new contribution margin would be $20,000 minus 6. New contribution margin would be 14. A lot, quite good. And from 14, if we subtract $12,000 of fixed costs, would be left with $2,000 of profit. So profit would remain the same, but operating leverage would be much better now, because operating leverage is contribution margin by net operating income. Then we are now more sensitive, and sensitive because we have, first of all, we have a lot more investment in fixed costs. Refer to my original video on cost volume profit relationships. There I said that if you are growing, if you're operating at above break-even point, then the capital intensive alternative, the one with more fixed costs, is going to give you better sensitivity. It's going to give you better acceleration, better multiplier effect. Okay, acceleration. Like for every 1% increase in sales, your operating income would increase by many more percent. So that's what happened here. Our new DOL is actually 7, because our contribution margin 20 minus 6 was 14,000, and our operating income was 12. So 14,000 by, sorry, operating income was 2. So 14,000 by 2 is actually 7. That means if there is a 1% change in sales, that would lead to 1 times 7, 7% increase in operating profit. So if there are 5% increase, if there is a 5% increase in sales, what would happen to our operating profit? Operating profit would go 7 times higher. So it would be 7 times 5, 35% higher. So that's the answer. Okay. So I hope you liked it, and if you enjoyed it, that's really gratifying for me. I hope to see you with some more solutions from this chapter, or if not, then my next video is going to be on activity-based costing. All right. Thank you so much for your attention, and please let me know how you go. In the meantime, I'm sure you have seen the new quizzes and new homeworks and new problem-solving questions. So please let me know how you go, and I'll be happy to help you. All right. Thank you.